Here is the key to your review. First thing we're going to do is find zeros. So to find the zeros of this function, I'm going to factor. This is a fourth degree, so I'll use grouping. You that are going to multiply give me that 36, and combined give me negative 37. So that means I'll get 36x to the fourth minus 36x squared minus x squared plus 1. Then factor out a 36x squared. So that's going to give me x squared minus 1. And factor out a negative 1 here. That gives me x squared minus 1. So that means 0 is equal to 36x squared minus 1 times x squared minus 1. So I can keep on factoring. Get 6x plus 1 times 6x minus 1, and x plus 1, x minus 1. So my zeros then will be plus or minus 1/6, and, oh, forgot my 1 there, plus or minus 1. There you go. All right, number 2. Factor this one. I'm going to start with my GCF. So that gives me x squared minus 5x minus 14. X times, this will be x and x. This is negative, so these are opposite. So that'll be a 7 and a 5. I'm sorry, a 7 and 2, 7 and 2 here. So my zeros then are negative 2, 0, and 7. All right, so now I have this graph. I want to know if the degree is even or odd, and if the leading coefficient is positive or negative. So up, up, so it has to be even. So I have an even degree. And since they're both up, this is a positive coefficient. Here, the ends are opposite, which means it has to be an odd degree. And it is going to have a negative coefficient. Okay, so the next part, we have to give the zeros their multiplicities and describe the effect on the graph. Okay, so this is already factored for me. That's nice. So I can get my zeros. That's going to be negative 4, negative 5/2, and 1. So negative 4, negative 5/2, and 1. So the multiplicity for this is 2. Multiplicity for this one is 5. For this one is 1. So since this is even, that means it's going to be tangent. Since that is odd, it is a point of inflection. And since this is 1, that means it just passes through. Okay, so number 6, I'm going to need to factor. So I'm going to factor out, I can factor out an x cubed, but I can also factor out a 3. So make sure your GCF is really the greatest common factor. So this leaves me with x squared plus 4x plus 4. So that means here, this is a perfect square trinomial. So this is 3x squared times x plus 2 squared. So my zeros are negative 2 and 0. So negative 2 and 0. The negative 2 is a multiplicity of 2. The 0 is, oh, it's cubed, is a multiplicity of 3. So this is tangent. And this is a point of inflection. All right, so now we're going to divide, either using synthetic division or long division. So for number 7, since this is legal for synthetic division, I think that's what I'm going to do. So I've got my negative 5 here. Then this is a third degree, so I should have 4 terms, 1, 2, 3, 4. Okay, good. So I got 1, 1, negative 17, and 15. A little place for my remainder. So bring down my 1. That gives me a negative 5, -4, 20, 3, -15, and 0. So my answer, 3 terms, it's going to be quadratic, so I get x squared minus 4x plus 3. There's my answer. All right, so number 8, this, I cannot use synthetic division, so I'm going to have to use long division. So 3x minus 2 goes on the outside. Inside, I'm going to have 9x to the 4th. Well, actually, I got to look here. I've got, it's to the 4th, so I should have 5. 1, 2, 3. I only have 3. So I've got to put my placeholders in here. So I don't have an x cubed. So it's plus 0x cubed plus 5x squared. I also don't have an x term, so plus 0x minus 12. I cannot forget my placeholders. So 3x goes into 9x to the 4th, 3x cubed times. So this gives me 3x to the 4th minus 6x cubed. Go in here, change my signs. So, oh, shoot. 3 times 3 is 9, not 3. That should be a 9. So those should zero out, and then I get a 6x cubed here. Bring this down, plus 5x squared. So 3x into here, I get 2x squared, positive 2x squared. So this is 6x cubed minus 4x squared. And this is going to give me negative positive. Those zero out, and I get 9x squared. Bring down my 0x. 3x goes into 9x squared, a positive 3x times. So this gives me 9x squared minus 6x. Change my signs. Those zero out. I get 6x minus 12. So 3x goes into 6x, a positive 2 times. So I get 6x minus 4. Change my signs. And going to give me negative 8. So my answer in the end then is 3x cubed plus 2x squared plus 3x plus 2 plus negative 8 over 3x minus 2. Okay? All right, number 9. Divide using long division or synthetic division. Okay, so again, not legal for synthetic division, so we're going with long division. So x squared minus 5x minus 5 divides into, this is a third degree, so it should have 4 numbers, 1, 2, 3, 4. Okay, good. So 2x cubed minus 11x squared minus 5x plus 4. So x squared goes into 2x cubed, 2x times. So I get 2x cubed minus 10x squared minus 10x. Change my signs. So those zero out. That gives me negative x squared plus 5x, and I bring down my plus 4. So x squared goes into negative x squared negative 1 times. So I get negative x squared plus 5x plus 5. Go in here and change my signs. So then these zero out, and I'm left with a negative 1. So my answer then is 2x minus 1 plus a negative 1 over x squared minus 5x minus 5. All right, on number 10, we are sketching this polynomial. So some things I have to know to sketch it. I have to know what the end behavior looks like. So that means I have to be concerned with the degree. So this is squared, so it'll be 2, 3, 4. So it's an even degree, positive leading coefficient. So here's my end behavior. I also need my zeros. So that's going to give me negative 1, 2, and 6. And I got something special going on here, right? I'm going to have to know to bounce. The other thing I need to do, because I'm sketching this and I have enough information for that, is I need to find the y-intercept. Okay, so the y-intercept is f of 0. So f of 0 is equal to, let's see, 1 times a negative 6 times a negative 2 squared. So this is a positive 4 times a negative 6, so f of 0 is equal to a negative 24. So my y-intercept is 0, negative 24. All right, so I'm going to go on here and mark this off. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And somewhere down here is negative 24. So I have points at negative 1, 2, and 6, and here at negative 24. So I want to think through this first. I know what my end behavior looks like, so I'm going to start up here. I'm going to come down. I'm going to have to hit that negative 24. I have to go back up at 2. I'm going to bounce and come back down, and then I go up in the end like that. So here's what it's going to look like. Start up here, come down, hit that negative 24, go back up, bounce, back down, and back up. So then I can double check my end behavior, double check my zeros, my bounces, my y-intercept, all that good kind of stuff. Okay, there we go. All right, so then I'm going to do the remainder theorem. Use the remainder theorem to find k. So the remainder, I have this function with a k in it. I have the remainder when it's divided by x minus 1. That means that 1 goes on the outside. On the inside here, this is a 4th degree, so I need 5. 1, 2, 3, 4, 5. So I don't need any placeholders. This is 1, negative 6, negative 3, k, and 2. And the remainder they gave me, it's negative 4. So this is 1, 1, negative 5, negative 5, negative 8, negative 8. So this will be k minus 8. 1 times k minus 8 is k minus 8. So k minus 8 plus 2 equals a negative 4. So k minus 6 equals negative 4. So k equals 2. All right, so we're going to do another one of those. So dividing by negative 2. This is a 4th degree. 1, 2, 3. I only have 4 terms, so I'm missing one. I got to pay attention to this. So I've got 4. This is my x cubed term. I do not have an x squared term, so I need a 0 there. And then k, and then negative 11. And then my remainder is negative 63. Okay. So bring down my 4. Got 4, negative 8, negative 11, positive 22, 22, negative 44, so k minus 44, then negative 2 times that, so negative 2 times k minus 44. So when I put all this together, I get negative 2 times k minus 44 minus 11 equals negative 63. So negative 2 times k minus 44 equals a negative 52. Divide by my negative 2, so k minus 44 equals 26. Add 44 to 26, and k equals 70. All right, 13. Now I'm going to use the factor theorem, which is still synthetic division, so it kind of looks like we're starting the same way. I know that x plus 1 is a factor, so negative 1 goes out here. This is a cubic, so I need 4 terms. 1, 2, 3, 4. All right, so I've got 2, negative 3, negative k, negative 12. Now, it didn't tell me about a remainder, but remember, because it's a factor, it divides evenly, so my remainder is 0. So bring down my 2. This becomes negative 2, negative 5, positive 5, negative k plus 5, and negative 1, or just negative, negative k plus 5. So negative k plus 5 minus 12 equals 0. So that means k minus 5 equals 12, and k equals 17. Okay, number 14. Negative 4 goes on the outside. This is a 4th degree, 1, 2, 3, 4, 5. Got 5 terms. All right, so 1, 4, negative 8, negative k, negative 12. Okay, the line's really crooked, but that's okay. We've got a factor, actually that bothers me. Oh, sorry, negative k, negative 12. Maybe I just need to erase this. There we go. Okay, so since it's still crooked, whatever. Since it's a factor, my remainder is 0. Bring down my 1, negative 4, 0, 0, negative 8, positive 32, negative k plus 32, negative 4 times negative k plus 32. So I get negative 4 times negative k plus 32 minus 12 equals 0. So negative 4 times negative k plus 32 equals 12. Divide by my negative 4, so I get negative k plus 32 equals negative 3. So negative k equals a negative 35, which means k equals 35. Okay, oh shoot. Okay, I need to fix this again. I changed this problem and I still didn't fix it on here. So hopefully the version that you look at in Schoology, this will actually be fixed. So what I changed is there's no 0 there, and this is actually a positive 1. So that should be, depending on when you printed it out or looked at it, what you see on your review. If not, change it to this. Okay, so now let's actually do this. So it says use the given zeros to write the polynomial function. All right, so remember we have our zeros. We have our y-intercept. We do not have a, right, the stretch. So when I write this, f of x is equal to the a that I don't know times, if this is a positive 1, that means I get x minus 1 multiplicity 2, this is squared. Times, this is not x minus 4/3. I have to work backwards on that. That's going to give me 3x minus 4. Okay, so now that I have that, there's nothing to clean up on the insides of these. I'm going to use my y-intercept to help me find a. So, because this, remember, this is f of 0 equals negative 8. So, negative 8 equals a. When x is 0, I'm going to get a negative 1 squared times a negative 4. So, I'm going to get negative 8 equals negative 1 squared is 1 times negative 4 is negative 4a. So, a is equal to 2. So there's my a. So my function, f of x, is equal to 2 times x minus 1 squared times 3x minus 4. And there it is. Okay, so we're going to do that one more time with a different set of information. So f of x is equal to a times, so I'm going to have x minus 3 times x plus 3. Then I will have x minus 2 square roots of 2 times x plus 2 square root of 2. So I can't really clean up anything inside of there, so I'll go ahead and use my y-intercept because this means f of 0 equals negative 72. So get negative 72 equals a times negative 3 times negative 2 square root of 2 times 2 square root of 2. Okay, so negative 72 equals a. Well, this is going to give me negative 9. 2 square root of 2 times 2 square root of 2 is 8. So it's a negative 8. So we get negative 72 equals 72a. So a is equal to negative 1. So f of x equals negative x minus 3 times x plus 3 times x minus 2 square roots of 2 times x plus 2 square root of 2. And there you go. 17. We're going to create a sine chart. So we just did this. This should be fresh in our brains. So in order to do that, I have to first factor and find all of my zeros. So I'm going to do some grouping here. Here I can factor out an x squared. That leaves me with 2x plus 5. Here I can factor out a negative 16. Leaves me with 2x plus 5. So then 0 is equal to x squared minus 16 times 2x plus 5. 0 equals x plus 4 times x minus 4 times 2x plus 5. So my zeros be negative 4, negative 5 halves, and 4. So for my sine chart, I'm going to put those on there. Negative 4, negative 5 halves, and 4. Then I'm going to plot my points. And I'm going to pick some test points and use them in here. So if I choose negative 5 plus 4 is a negative number. Negative 5 minus 4 is a negative number. Negative 5 times 2 plus 5 is still a negative number. So overall, this is negative. Between negative 4 and negative 5 halves, I can go with negative 3. So when I substitute in a negative 3 here, this is going to give me positive. Negative 3 here is negative, and negative 3 here is negative as well. So overall, this is positive. If I was between negative 5 halves and 4, I could pick 0. So that's going to give me positive, negative, positive. Positive, negative, positive. Negative overall. Then I can pick 5. Oops, that'll give me positive, positive, positive. It is positive overall. Then I shade, and I'm going to get negative, positive, negative, positive. And this one just said create a sine chart, so bam, we did that. The next one's an inequality, so we have to create the sine chart and give the answer to the inequality. So I have to get all my variables on one, or all my terms on one side first. So I'll move everything to the left. I have a 7x cubed, and I'm going to add 5 to that, so that's going to give me 12x cubed minus 10x squared minus 12x is less than 0. So then I factor. So I get x, actually, well, I can factor out an x, but remember I want the GCF, not just the CF. So I can't factor out 12, can't factor out 6, but I can factor out a 2. So that's going to leave me with 6x squared minus 5x minus 6 less than 0. I'm not dropping anything off here. So then I can factor by grouping. The 6 times negative 6 here is a negative 36. So that means if I have 2x, and that will give me 6x squared. I can do a negative 9x and a positive 4x minus 6 is less than 0. So 2x. Here I can factor out a 3x. That leaves me with 2x minus 3. Here I can factor out a 2, and that leaves me with 2x minus 3, all less than 0. So 2x times 3x plus 2 times 2x minus 3 is less than 0. So my zeros are negative 2/3, 0, and 3/2. So on my number line here, I'm going to put a negative 2/3, 0, and 3/2. Plot my points. And then let's test some and figure out our signs. So something less than negative 2/3, I can go with negative 1. So negative 1 in here is negative. Negative 1 in here is negative. Negative 1 in here would give me negative. It's negative overall. Between 0 and negative 2/3, well, it's going to have to be a fraction. Why don't I use negative 1/3? So negative 1/3 right here is going to be negative. Negative 1/3 times 3 is negative 1, plus 2 is positive, and then negative 1/3 in here will give me negative also. So between 0 and 3/2, I can use 1. So that would be positive. 1 in here would be positive. 1 in here would be negative. So it's negative overall. Then on the other side of 3/2, I could use 2. So this would be positive, positive, and that would give me 4 minus 3, so that's positive. So this is positive overall. Oh, and you know what I just realized I did? Dang it. I plotted my points, but I didn't pay attention to this. This is just less than. It's not less than or equal to, so these are actually open circles. So you pretend like that's not in there. Or open circles. Yeah. All right, so then, sorry, I just got distracted by myself because I caught my mistake. And since it's less than, we're going to be talking about negative. So when I shade down here, up here, down here, up here. And then I have to give my actual interval since it's an inequality. So I want the negative. So it's negative from negative infinity to negative 2/3. And then because they're open circles and it doesn't say equal to, I do not include that 2/3. Then I start back over here at 0 and go to 3/2. And again, I do not include either one of them. There is my negative intervals. Okay. All right, so now we're going to use the sign chart, just the sign chart, to sketch this and use my signs correctly and my zeros correctly. So my zeros here, I have one, or actually I'm going to shade first. So this is positive, positive, negative, positive. So my zeros are here at -3, 1, and 3. So here I'll go 1, 2, 3, 4, 1, 2, 3, 4. So I'm at -3, 1, and 3. Right? -3, 1. Sorry, on my board these look, I can't tell if my numbers are right. I think that's right. Okay, so what I don't know here that I did know on the first sketch I did. On the first sketch I did, you had the equation so we could figure out the y-intercept. Here, I don't know the y-intercept. I don't have enough information to find it. This is all I've got. So what I do know from this, though, is that since this is positive, positive, I'm going to start up here with my graph. It's going to bounce off of that and stay positive, right? And then it's going to have to come back down to be negative and then back up to be positive. So I got to make sure that I bounce at that -3. And I start, it's up, up. So I start up here. I'm going to bounce. Okay, I'm going to come back up. I have no idea where my y-intercept is. I'm going to go down through here. Then I have to go back up and I end something like this. So your graph should look something like that. Of course, the y-intercept we don't know, and we don't know our max and mins. So yours could be, you know, longer and skinnier there, whatever. All right, so now we're going to do the complete factorization and find all of the zeros. So on number 20, set it equal to 0. I can get to 4th degree, but I can factor it to x squared. X squared, this is negative, so the signs are opposite. So two numbers that multiply to give me 72, that would subtract to give me 14. So 8 and 9 should be like the first ones that kind of pop into your head. And so if we think about 8 and 9, obviously they're not going to subtract to give me 14. But if you're having trouble coming up with other factors of this, think about taking these apart. If I divide this one by 3 and multiply this one, so I could have 18 times 3. Well, that's not going to give me the 14. Or what if I divided this in half to get 4? That 2 I divided out, I got to multiply by this, and I get 18. Well, guess what? 4 times 18 is 72, and it would work here. So this is going to be a positive 18 and a negative 4. So learn how to manipulate your numbers. That's why number sense is so, so important. 0 is equal to, well, this is still x squared plus 18. Then this is going to give me x plus 2 and x minus 2. Okay, so then I'm going to solve these. This is going to give me x equals 2, x equals negative 2, and then this will give me x squared equals negative 18. So x equals plus or minus the square root of negative 18. So I know that negative comes out as I, and then I have to simplify the square root of 18. Well, 18 is 9 times 2, so the square root of 9 is 3, so 3i square root of 2. So there are my zeros. So x equals, I've got plus or minus 3i square root of 2 and plus or minus 2. Okay, so there are my zeros, but then I need that complete factorization. So that means that I have f of x equals, so I'll have x minus 3i square root of 2, x plus 3i square root of 2, then x plus 2, and x minus 2. Okay, last one. Going to need to factor this. Well, almost looked like I had a GCF, but that doesn't have a 3 on it, so can't do that, but I can use some grouping here. So here I can factor out an x squared, leaves me with 3x plus 1. Here I can factor out a negative 12, so then that gives me 3x plus 1. So I get 0 equals x squared minus 12 times 3x plus 1. So that's the best I can do right now with the factoring. Solve these. So this would give me x squared equals 12. So x equals plus or minus the square root of 12. Then I have to simplify that. So 12 is 4 times 3, so that's 2 square roots of 3. And then this becomes x equals negative 1/3. So my zeros then, I have negative 1/3 and plus or minus 2 square roots of 3. There are my zeros. My complete factorization, f of x equals, so I can do x minus 2 square root of 3, x time, or plus 2 square root of 3. And then here, I do not get to just plop that negative 1/3 in there. This is 3x plus 1. Okay. And there you go.